Hello, 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 hello. Can you hear me? Can you hear me? Can you see the screen? Yes. Okay. Last class, let's start our class today. Last class, what we have done? Last class, we learn what we have learned there in last class. Last class, we have completed the one exercise problem. Now, uh, so for what we have completed the composite area, and then one example, one another exercise, then another exercise. Then today we'll start. Today we'll start. I will show you this one. One. Uh, how to say? Locate the centroid of the rod bent into shape of a parabolic arc. Bent into the shape of the parabolic arc. We'll start that one. Right. So start for a second. Where is the paper? Right. So this is the our problem. This is our problem. We're going to study now. So what is the problem is telling us here? Let's find the now two things we learned there. Uh, Two things. We have learned that centroid of the locate the centroid of the rod bent into the shape of the parabolic arc. Now as I told you, there is third type. Another one type we learned the composite area combination of some area. Another we learned kind of the continuous, if it is continuous line block. But now we learn some line, center of a line. So rod is a kind of the line here. So rod, one is a rod, center of the rod. So rod dimension is given here. Rod dimension is given here. 1 meter here and 1 meter there, and this is the rod. So look at the centroid. In order to centroid, we assume the very small length dl. dl is very small length. Suppose we assume that dl. Now please understand the difference between the previous example. In previous example, we assume very small strip dx. We assume very small strip dx, and here, but if in case of the rod or something length, something the line, we will assume the very small length. So we assume the very small length. This is the very small length. we consider the very small length. Now dl, so if we draw this in a bigger, very small, so but this is the dl, okay, dl. Now this is the dl, but if we consider horizontal, it is actually dx, and it will be dy, okay. So dl equal to actually dx square plus dy square. From the Pythagoras formula, we already know it, right? Now if we take the common, what is dl, if we take the dl common, dy, so what is happening, dy square, so here is 1 dy square, so here will be dx by dy, okay, dx by dy, and here will be dy, right? Now we can write down dy. So in both sides we divided by dy, then dy equal to dx square dy whole square plus 1 and dl, multiple dl. So this dly come this side, dl. All right. Now here what we have the formula. Our formula is x equal to y square. Our formula equal to x equal to y square. So if x equal to y square, formula means the rod shape is in such a way, we can write down x equal to y square. So we can write down dx equal to twice dx equal to dx by dy equal to dx by dy equal to twice y. We can write down that. We can write down from here to here. We can write down. So from here dl equal to, we can write down dx by dy equal to y. So we can root over 2y square plus 1 and total a in dl. That we can write down this. Now here, now this is equal to dl. The why, and one thing you see, the like previous example, we assume this is our very small length, and center is x bar. X bar is with x distance, and y bar is at y distance. We assume that, okay. Now if we assume that, now I open another one. Assume that. Now previously we learned the formula. One simple formula. Yesterday we learned formula that x bar equal to, for integration, x bar integration, what we learned, the integration of the small a and integration x a, right? It is for area. It was for continuous CG, center of gravity, bounded by the continuous line. But here in our case today, is, what is our case? Our case is line, right? Is a line. So here our formula is little bit changed, same formula, but only change dl. It is dl into x bar dl, So here, so x bar equal to we can write down l. Our formula is l into dl. So dl equal to, just we write down what dl equal to, we know this one, right? 2i6 square, 2i mean more clearly we can write down this one equal to root over 4y square plus 1 dl. Okay, 4 square sorry, not dy, dy here, dy, sorry, I was writing wrong from the beginning, sorry. What is it? So dy will be multiplied by there, dy will be multiplied, it will be dy, and it will also dy. So d equal to, so here we can write down dl equal to integration of dl equal to, we just learned, what we learned, 4y square plus 1 dy, right? And x bar equal to, what we learned there, x bar equal to x, where x bar equal to x, we found the very small up to center, right? Okay, now integration of, and we are doing integration from here we can write down here. It is integration to with respect to y, right? In integration with respect to y, and y value is varying from 0 to 1. 0 to 1. So we will write here. We will write here 0 to 1, and here also integration 0 to 1. X bar equal to x. So we write down x and dl, and dl equal to, already we have 4y square plus 1 dy, right? 4y square plus 1 dy. So this is the our formula. Now this equal to x bar. Now one thing, can you do this calculation, bottom part or the top part, in your calculator? Tell me please, can you do it? I think you should do it. You should know how to do it, right? Your calculator, using your calculator, using your calculator. If you cannot do it, I think you should, calculator will be more faster. If you cannot do it, here we have formula, similar formula. Here we have, what is the formula? We have formula here is similar. You see this one, x square plus y square, root over x square y square. Come on here, what this? So x square plus y square. This is the formula. This is the formula, right? If we do our problem, compared to our problem, so what is our problem? X square. So in such a way you can do this, right? So can you remember this formula you learned in high school? Tell me please. Here in this example, 4x square. So the problem will be like this. In our case, in your case or our case, 0 to 1, 4x square. Here root over 4. Come on, not working. Why not working? I don't know. X square. Sorry, why? Should work. Okay, s square plus formula a square is not working that side, so I will work there. Let me find it. So what is integration x square plus a square, right? Root over. So here in our case, x square is actually 2y square root over, and 1 equal to plus 1 equal to 1. So after that you put all the formula here, and then you will get the and what is the answer? I wrote that for you. If you haven't calculated yet, I write down for you the here. So 0.63, and bottom will be 1.479, and finally answer will be 0.410 meter. 0.410 meter. Now similarly, y bar will be same formula, just only here y bar formula is more simpler, just the y bar dl and integration of the dl, integration of dl. Now here y bar equal to how much? Y bar equal to is showing y bar equal to y. So simply you put the formula, simply you put like this, 0 to 1 y whatever. If you want to put the as per the formula 2s or 1 square, as per you want to put in the formulas, and it will be like this, 1 and 1 2y square plus 1 square and dy, and finally you do the calculation. This is it will be same 1.479, and top should be 0.84, right? And then result is 0.574 will be, right? 0.574 meter. So you have any question? Tell me please. So here is the answer, right? Tell me please, you have any question so far? 7.323. Are you there? So response your name call, please. Response your roll call, please. Before that, I want to tell you. So next class is your next class. Next Thursday, Yom Khamis. Next Thursday is your last quiz. Okay. This chapter, suppose we take this chapter 9. Okay, this chapter, and here is the end of this chapter. Okay, so far we have covered everything. Here is the end of this chapter. One thing is there where I skip it. Maybe you can learn by yourself if you are interested, and that is the Pappus-Golding theorem. Pappus-Golding theorem. The Pappus-Golding theorem. Okay. Pappus-Golding theorem. What is the Pappus-Golding theorem? Pappus-Golding theorem is this one. Pappus-Golding theorem is something with the volume, but we skip it. If we have time, next time fluid pressure, we skip it. If we have time, then we'll come to do it. Otherwise, we skip it. This Thursday, yes. This is week 13, right? Week 13. Yes, week 13. This Thursday, you will have this quiz, and this Thursday, yes, it is week 13, yes, and week 14, hopefully, will be the last week for us. Okay, hopefully. Now, if you don't have any question, so I want to ask your attendance. So Muhammad Aziz is there here, right? Muhammad Hafiz is there, right? Abdul Aziz Mazen is there, right? Kumail Hassan, there. Muhammad Abdul Aziz bin Hussain Zafar. Muhammad Abdul Aziz, not there, right? Okay, absent. Muhammad Abdul Aziz is not there. Muhammad Ahmad bin Abdul Rahman. Muhammad Saad, I didn't ask you, Muhammad Saad. When your turn comes, then you answer me. Muhammad Ahmad bin Abdul Rahman, you are here, right? Muhammad Yusuf bin Yusuf is there. Muhammad Sami. Muhammad Sami bin Muhammad Sulaiman. Muhammad Sami. Muhammad Sulaiman, absent. Ahmad Tahir bin Ahmad. Ahmad Tahir, absent. Abdullah Muhammad bin Abdullah. Muhammad. Abdul Malik Khaled. Abdullah Muhammad, absent. Abdul Malik Khaled, present. Omar Abdul Aziz ibn Salem. Umar Abdul Aziz is not there. Ali Abdul Munaim. Isa Abdullah. Yahya Abdullah. Muhanna Walid. Talal Jamal. Saud Usama. Hussain Ali. Faris Fahad. Abdulillah. Ali Jawad. Hussain Abdullah, Ahmad Imad, Abdullah Saadun, Ahmad Dia, Muhammad Saleh, Muhammad Salah, Hussain Jawad, Faraz Fadel, Abdullah Saleh, Saad Muhammad Saad, Abdul Munaim, Abdullah Saad, Umar Wahid, Muhammad Shabir, Muhammad Shabir absent. Shamsan Saleh, Umar Ahmad bin Umar. Muhammad Shabir is there, right? Umar Ahmad absent. Jamal Raed, Kamal Ashraf, Umar Usama, Abdul Nasir, okay. Musa Muhammad absent. Abdullah Said, absent. So double check, I'm asking you again. Sunday, Muhammad Abdul Aziz bin Hussain here. Muhammad Abdul Aziz bin Hussain absent. Muhammad Sami bin Muhammad Sulaiman, absent. Ahmad Tahir absent. Abdullah Muhammad bin Abdullah absent. Abdul Rahman, who is that? Umar Abdul Aziz. Umar Abdul Aziz is there. Okay, there. Okay. Then Umar Ahmad bin Umar. Umar absent. Musa Muhammad Isa. Is there. Abdullah Said is there. Abdullah Said is not there, so absent, confirmed. Okay, then it's done, and so this is end of this chapter, and we are going to start now new chapter. New chapter is chapter 10, moment of inertia. Okay, so we'll start now new chapter, moment of inertia, and tell me, what do you mean by moment? What do you understand by moment? Doctor, the grade of the last quiz when will be? Inshallah, hopefully I will give you. I'm working on it now, so I will try to give you best on before Thursday next quiz. Okay, I'm working on it. All right, Hussain Abdullah. All right. Okay, not okay. Okay. So tell me what do you mean by the moment? Moment of inertia. We are now. Tell you understand. You know already what is moment. Tell me moment. You know the moment, right? Moment definition. What you learn? Force into distance. Something like this, right? Something like this. Now, moment of inertia sum is also kind of the moment. And what is the moment? Here is, we will learn it, that one. So method to determine the moment of inertia of an area. So here we will actually learn moment of the area. Suppose we have some area, this is the area. What will be the moment of inertia of this area with respect to this axis y? What is the, with respect to this axis, what is the moment? Or with respect to this axis, what is the moment of this area? If we take the small part, or if we take whole part, whatever the moment, right? Introduce product of inertia, This is something different, like something new thing. So show determine the maximum minimum moment of inertia of the area. Discuss the moment of motion. Maybe we will not do this. Maybe we will be up to here. Okay, up to here. If we have time, then we will do this. Okay. So chapter is the different. We'll do this one. Maybe moment inertia, parallel axis theorem. This is very important. We learn this. This is very, very important. Radius of gyration of an area. Radius of gyration. Maybe if we have time, composite area. This is very important. We'll do this. Product of inertia. It is also, we also do it initially about the inclined axis. If we have time, then we'll do. Otherwise, no. This is not. Will not do. This is will not do. Time will not allow. Time will not allow us, and it is a little bit complicated. If we have, so we will stop here, right? And so now definition of moment of area, right? Centroid of an area is determined by the first moment of area, right? Now, what is we learned there in just previous chapter, chapter 9? We just closed the chapter 9, right? What we learned there? Can you remember the formula? dA equal to this formula. We just had few minutes ago we finished this chapter, right? Tell me, you remember this? Answer me, please. Yes, you remember this, right? Actually, what is this? What is this? Actually, what is this? This is actually moment of area. This is moment of area. What is moment? Area, moment of area. What does it mean? dA. Now we learned before, the force into distance is called moment of what? Force into distance, actually moment of force. Moment of force. So if it is a moment of area, then what we'll do? Just we delete the force, we write down area. That's it. And distance, area into distance. So dA into x kind of distance. So this is actually moment of area. Moment of area. If we do y into dA, it is with respect to, it is what? With respect to x, with respect to y axis, y axis. Like x distance is determined from y axis, right? With respect to y axis. And dy, it is dy with respect to x axis, right? With respect to x axis. So this is also moment. This is also moment of area. Moment of area, right? Clear? This is clear? Tell me, please, yes or no? Yes, right? Just we finish last chapter, but last chapter we didn't tell you actually what is this, because that time it was not necessary, but now it is important to understand actually x into dx. Actually x into dA, it is area of moment. This is area of moment with respect to y-axis, and it is area of moment with respect to x-axis. It is called it. Now tell me, what is the power here? X power is how much? Tell me. X power is how much? Power of x is how much? Tell me. Power of y is how much? Tell me. Tell me how much? 0, 1, 2, 3. How much is the power? Tell me, please. Power of x or power of y? Is 0, 1, 2 or 3? What is the power here? Talal Jamal, Hussain Ali. 1. Abu Salim 1 is correct. Power is 1. That's why its name is actually first moment. First. That's why its name is FIRST, first moment. So centroid for an area is determined by the first moment of area. Okay. Centroid we completed the last chapter, but actually what is this is understood in this chapter. Centroid is a first moment of area. First moment of area. Okay. Now if we multiply with the another x, so it will be x square, right? It will be x square, and it will multiply by another y, it will be y square, and then its name will be what? Its name will be second moment of inertia, second moment of area, second moment of area, second moment of area, and this is second moment. If you multiply with another x, then that means x square dA and y square dA is a second moment of area. Is another name is moment of inertia. So what is moment of inertia? Moment of inertia is moment of second moment of area. Second moment of area. So this is moment of inertia with respect to y-axis, and this is moment of inertia with respect to x-axis, right? So second moment of area is defined as the moment of inertia. Now clear what is moment of inertia? Tell me please, yes or no? Yes, right. It's called second moment of inertia. Moment of inertia. So moment of inertia of an area originates whenever one relates to the normal stress sigma or force per unit area. Now one example, you see one example. Suppose this is water. Under water there is some kind of the body. Suppose you are swimming, right, underwater, and your body underwater, right, and somehow your chest, you feel the pressure of water. So suppose this very small area we selected, right, and there is a what F is a force or pressure dF and dy. So you are feeling the pressure in differential area in your body with F, right? So if you integrate, it will tell you all the pressure is working there. All right, and this is the example of the moment of inertia, right? Then so whatever we told you, I have shown you just in previous example here, the x square dA and y square dA, right? Same now this is coming at now here. Now suppose some area we have, and this is a very small area, right? Very small area dA, this area dA, and we take the y square is the second moment of inertia with respect to x-axis, right? With respect to x-axis, right? And if we integrate it with area A, total area A, and this is with respect to y, usually with respect to x-axis, right? Because y with respect to the distance is covered axis, so Ix this is. And similarly, if the x square dA, then x square is usually with respect to y-axis. So this is Iy, and this is the same formula, right? Just wait a moment, please. Sorry, please wait for a moment. Yes, and this is we write down as a I. So this is the Iy. That means moment of inertia with respect to axis y, with respect to axis y, this is y is equal to x square dA, and momentary inertia with respect to x-axis is this, right? Okay. All right. So finally, we found this is the very, very important formula, right? Okay. Then moment of inertia, if it is the x-axis and y-axis, if it is the x-axis, this formula with x-axis and y-axis. Whatever, if it is with z-axis, what is the z-axis? Z-axis is perpendicular to x-axis and y-axis, x-axis and y-axis, and this is z-axis. Iz equal to actually r square dA, integration of a, because this is r, integration r dA equal to r square equal to x square plus y square, right? dA. So we can find it. Ix plus Iy. So z equal to actually z equal to Ix among Ix and Iy. So polar, it's, and z with respect to z axis, it's got polar moment of inertia. However, maybe we will not use this one r square dk. Maybe in this chapter we will be confined, or we will only limited to learn Ix and Iy. Okay, so today maybe we will learn only formula and theory. If we have time, we will do some example. If we don't have time, maybe next class we will do some example, right? But here you think that, here you see that the two example, right? Here remember the x distance is is distance here up to center up to is y distance and x distance, but here may be something different. You can see, right? Our axis, our you need to understand, we need to understand more clearly here. I delete them and do it again. It's very important to understand, right? The distance, this is very important one thing. Suppose if our selected area is here, and this is our original x-axis and y-axis, then this is the formula. Then this is the formula this. But if our axis is actually here, our original axis from where we want is here, and we want the moment of inertia from of this area. From here to here is distance, suppose y bar. This is x prime axis, this is x prime axis, and from here to here distance is y axis, and from here to here is distance x prime, right? So if we do the our center here, then is formula is there. But if our axis is there, then what? Then what is the formula? Then what is the formula? That answer is here. That answer is here. So our we have x prime and center is there. Center is there. Now with respect to this one, our Ix equal to will be y square, y prime square, because it's y prime distance, dA, right? Ix prime, this is prime, right? Ix prime equal to this. But with respect to this one will be Ix equal to what? This is how can we decide? If our distance change, our axis change, then what will be our formula, right? This is answered by the parallel axis theorem. This is answered by the parallel axis theorem. Okay. So what is parallel axis theorem? For moment of inertia of area known about an axis passing through its centroid, and determine the moment of inertia of about a corresponding parallel axis. So this is the parallel axis. This is parallel to parallel. This parallel, and this is parallel to parallel. So it's parallel axis using the parallel is called parallel axis theorem. Parallel axis theorem, right? What is the formula? Formula is this. What is the formula? Formula is this. Okay. Here, parallel axis formula equal to this one. Parallel axis formula is this. Ix equal to Ix bar plus AD square, Iy equal to Ix bar. What is this? What is this? Suppose some center we have, some center, and it is its moment of inertia. You already know Ix is going to the center of the body. It's going to the center of the body. I draw it again. Maybe I need to draw it again. Suppose we have a small area, right? And its center is here. I'm drawing. Its center is there. CG. Just you learned, right? CG is there. And the X is green color, also going through the CG. And there its moment of inertia is I bar. Usually, as I told you, that center we show by x bar, y bar. Similarly, moment of inertia with respect to the CZ, centroidal axis, it's called centroidal axis. What is centroidal axis? The axis passing through the center, passing through the center or center of gravity is called centroidal axis. So centroidal axis also determined by the bar. In x case x bar, and if it is y, then it is y bar. Okay, so suppose the centroidal axis, through the centroidal axis is moment of inertia I, right? Now another question is any axis parallel to this any axis. Suppose I give x prime name and y prime name, right? So what is the moment of inertia with respect to this axis? Then what is the x prime? What is the x prime? So x prime formula is Ix, first this one Ix plus area of this one, area into what? Distance from here to here, distance from this axis to that axis. Remember and learn it very clearly, right? Be attentive here, right? Dx, and suppose this distance is d, usually it is dy, right? Because in y distance, so dy square. So this is called parallel axis theorem, right? So with respect to any axis. And similarly for iy prime, this is ix, this is x prime, right? So iy prime equal to what the formula will be? Iy through the center plus area into from center to center, here to here distance, and this is you will write down as a x. So dx is square, right? So this is called parallel axis theorem, right? This is called parallel axis theorem. So with these two equation is very important. Why very important? We can determine moment of inertia with any axis, anywhere in the world, any axis parallel to centroidal axis, So suppose here your area is here. Now you want to find it from here, right? Suppose this is, give some name. This is the example. This is axis number k. It doesn't matter. This is k. This is axis number. Axis name. Give some name. Just m, right? It doesn't matter. So I k equal to any axis equal to first is centroidal axis. This is always will be same, right? Centroidal axis Ix bar, first Ix bar plus area of this plus area into distance. What is the distance from here to here? Any distance, right? Any distance d. Suppose give some name dm, right? So up to here dm. With respect to any axis you can calculate. Now Im is give you name, right? Im equal to I. What is the distance? What is the with respect to this axis? What is the central moment of inertia? Is Iy bar. Always remember bar plus a into d. What is the distance from here to here? Distance here to here. Here. This is the center, right? Center to center distance. Okay, center distance. So center distance. Suppose give some name, any name, dk. So dk. Here square, here also square. So this is called parallel axis theorem. So if we know the moment of inertia with the centroidal axis, so we can find any other axis. We can find with respect to any other axis, and that is called parallel axis theorem. All right, clear or not clear? Tell me please. Clear? Do you have any question? Clear, right? Yes. So two formula and concept you must have to remember. Today we will not do any calculation. Next class I will start a calculation, but before we the next class, before I go to the next class, you must have to clearly, very clearly understand that two things I discussed today. One is moment of inertia with respect to centroidal axis x and y, and Ix is with respect to any other axis. This x means any other axis in the world, any distance, doesn't matter. We can calculate if we know Ix and just area and into the distance to the center, right? dy, and y equal to y bar plus a dx square. So what is the distance? Remember, the distance is this centroidal axis. The distance is this one, this center, from this axis to this axis, centroidal axis distance is dy, and from this axis to centroidal axis dx. This is the distance only. So these two is very important. Next class we will learn something different and other thing. Those things next class we'll learn. Our time was finished, so if 1 minute time we have, if you have any question, you can ask me, please. If you have any question. Tell me, please. Any question? No question? If you have no question, then we can finish here, and next class we will start from there. All right. So next class is very important. I will show you something very important.